So we are only left with electric potential energy from the topic potential. Rest of the portions we have covered. This was included in your potential. Now regarding electric potential energy, see, whenever you have energies, different types of energies available in the system. You have kinetic energy, you have potential energy. So mainly in nature, kinetic energy comes due to why? Due to change in position, motion basically. Whenever a body is in motion, then kinetic energy gets associated with it. Reason behind potential energy is the interaction between two masses you have, two charges you have. It's not necessary that it's only charges. If you have more than a single charge with you, Q1 and Q2, what will happen? Both of them will interact with each other. When I'm using the term interact means both of them are exerting force on each other. If I have this charge Q1 with me, and there is no other charge present. So see what will happen if only Q1 is there and no other charge is present. Then Q1 has no other charge to exert force on, means it has no other charge to interact with. So I'll definitely say the potential energy of this is zero. But if I have more than a single charge, like example this Q1 and Q2 with me, then what will happen? Both of them will exert force. So this interaction results into potential energy. So potential energy is not only caused due to change in configuration, change in size, shape. Potential energy, the main cause of potential energy, this comes due to interaction between two objects. Two charges are present, be it two masses are present instead of charges. If you have M1, M2, then you have gravitational potential energy. So if you have Q1, Q2, then you will have electric potential energy. So the reason behind potential energy is what? The reason behind potential energy is the interaction. And by interaction, I mean the force exerted. Force exerted on them. So let me write the reason of potential energy. So electric potential energy, cause is what? The cause is the electrostatic interaction. So if you have a single charge with you, that single charge will be having its own potential. That single charge will be having its own electric field. But since there is no other charge present along with this charge, what will happen? Since no other charge is present, there won't be any interaction, means there won't be any force generated. So resultant will what happen? The potential energy will be zero. Now you can relate potential energy with work done. If I say I have some charges at infinity, let's say this is infinity, and I have some charge Q1, Q2, Q3, these are some charges located at infinity. Now what will happen? If I bring up this charge Q1, this is my system. Right now there is presence of not a single charge. Then I somehow bring this Q1 from infinity to here. Now tell me, is there any other charge apart from Q1?
No, ma'am.
Right now there is no other charge apart from Q1. This is the first charge that has come. It means there is no other charge present to interact with Q1. So what will happen? Q1's, all the work done that is required, there won't be any work done actually. Why? Because there is no other charge present with Q1. Now if I bring this Q2 like this over here, so now there will be some forces generated, Q1 and Q2, now they can interact with each other. Similarly, if I bring up this third charge also from infinity, I say this is Q3. So Q3 will also be at a certain separation from Q1 and Q2. And Q3 will also be exerting its force on Q1 as well as Q2. So all the work done that is required to make the system means what? To carry these charges, to basically assemble all these charges. From where? From infinity to my arrangement, respective position. all the work done to make the system, this whole work done gets stored in the form of potential energy. And this is what we call as the electric potential energy. Electric potential energy is what? It is the work done by what? The external force. See, we are bringing these charges. The external force is bringing up these charges. So work done by external force in carrying charges from where? From infinity to their respective assigned position. Is this clear? Reason of electric potential energy, what is meant by this? I'll write the definition also. So see, electric potential energy, this is what? Electric potential energy. This is basically the work done by what? Internal force or external force?
External force.
External force. Work done by external force in carrying the charges. In carrying the charges from where?
Infinity.
Infinity. In carrying the charges from infinity to a particular point. Basically, what I've told you just before, how to assemble the system that we had seen right now before erasing that part. Q1, how Q1 has been brought from infinity, how Q2 has been brought from infinity, and so on. So just write down these two lines, then we'll calculate how to calculate the potential energy if you have two charges with it.
Can you explain the first line?
This cause one, Atif?
Yes, teacher.
See, potential energy comes when the reason behind the potential energy. See, you have various kinds of energy. You have total energy. Total energy is what? Total energy means the sum of all the energies present in the system. It means total energy must be having internal energy of the system. It must be having kinetic energy of the system. It must be having potential energy of the system. Now see, there are different reasons for all the different energies available. Now, if I talk about internal energy, this comes within the system. If I talk about kinetic energy, then kinetic energy comes whenever there is change in motion, whenever a body is in motion. That's why we write the formula as half mv squared. No, because of the change in means basically it is in motion. Now, regarding potential energy, we have studied what? Whenever there is change in configuration, change in shape, change in size, the energy associated is potential energy. But this is not the complete answer. Regarding potential energy, the main cause of potential energy is when you have two bodies which can interact with each other. Now see what is meant by this interaction that I am writing. If I have two masses with me, let's say this is mass 1, this is mass 2. Had I not be having this mass 2, M2, then M1 mass 1 would not be having any mass to interact with, as in to exert force on. Now see, if M1 and M2 are present, these are two bodies having their respective masses as M1 and M2. What will happen? Both of them will exert gravitational forces on each other. So the energy that is associated right now, because both of them are exerting force on each other, that is known as gravitational potential energy. Similarly, if I have a single charge Q1 with me, it is not interacting with any other charge present. If I bring up another charge Q2, now they can exert force on each other, they can interact with each other. It means they can generate energy. So that energy that comes due to this interaction means this exertion of the force, that is known as electric potential energy in this case. So this is the cause of potential energy, no? So the way we are getting gravitational potential energy over here, the way we are getting electrostatic potential energy. So the basic cause behind potential energy is interaction. If I bring up a third charge, Q3, now see, there will be energy associated with Q3. Now Q3 will be interacting with whatever charges, then that number of energies you will be getting. Like if you have Q3, so Q3 is interacting with Q1, Q3 is interacting with Q2. It means you will be having two energies. If I bring up another charge, Q4, so Q3 will be interacting with Q4 also. So Q3 will be having three energies. So how are we calculating the energy of Q3? By counting the number of interactions. This is what is meant by electrostatic interaction. Is this clear now?
Yes, teacher.
Now see, potential energy between 2 point charges. We are taking the minimum case. So minimum we have to have two charges, because with the help of a single charge, potential energy cannot be generated. So we are taking the case potential energy for 2 point charges. Now see, I am repeating again. For making up the system, all the work done that is required, we are calculating that, because this work done only gets stored in the form of potential energy. Now see, if at infinity, I have charges Q1 and Q2. 2 point charges I have Q1 and Q2. Now, let us draw it in graphical manner. So this will be easier to understand. This is y-axis, this is x-axis, this is origin. Let's say I have brought this first Q1 from where? From infinity to a point. Let's say this point is A. I have brought this Q1 now. From infinity, I have brought this to this point. And let's say the separation of this point from the origin is R1 vector. This is Q1. Now, since Q1 has no other charge to exert force on, what about the work done? Work done in carrying Q1 from infinity to a point. All the work done, since there is no work done in carrying from charge Q1 from infinity to this point O, W1 will be equal to 0. Reason? Because there is no other charge present. This is the first charge that we have brought into our system. Now, work done W1 is 0. But what about Q2? If I bring up Q2, let's say this is some point B, this is Q2. Let's say the separation, the coordinate of Q2 is R2. So relative separation, if I talk about relative separation, means the separation between Q1 and Q2. This will be what? This will be R12. Let's say R12 is the separation between point A and point B. Now, I have to calculate the work done because now this time work done won't be 0. There will be some value of work done. Reason being that Q2 is there and Q1 is exerting the force. Now see, what was the formula of potential that we had studied? Fatima Munir, you tell me. We had studied potential, the definition of potential. It had a formula which it related with work done. So how can you relate work done, charge and potential? Hint is that you can relate it by the definition of potential. So yes, Fatima. Yes, Fatima Munir, are you able to understand the question? There is some relationship between work done, charge and potential. That comes from the definition of it only. Hamza? Yes, Hamza? Anyone else?
Ma'am, electric potential is the work done in carrying a charge from infinity to a point.
Perfect. See, rest of you who were not able to recall. Definition of potential is this only, no? Work done in carrying the charge, a unit positive test charge. So what will be work done? Work done will be charge multiplied by potential. So work done in carrying Q2 from infinity to point B. This is charge means Q2 multiplied by the potential difference. Now potential difference is what? Whenever I say potential difference or any difference, it means final minus initial. This is final minus initial. So final potential is at what point? B point. Means this is VB minus initial potential at infinity. So this is V infinity. Now regarding VB, potential at point B is generated by what? It is generated by Q1. Q2 has been brought, but the potential is generated by Q1 only. So formula of Rishan Mirza. Yes, Rishan. You tell me, at this point B, if Q1 is the charge, R12 is the separation, what will be the potential? Yes, Rishan. Kulsum?
Yes. Can
See,
you repeat it, ma'am?
See, the general formula of potential is KQ divided by R. At the point B, potential is being generated by charge Q1. Separation of Q1 and Q2 is R12. So what will be the potential at B because of Q1? See, constant K will be there. Charge will be what? Q1 or Q2 if potential is generated by Q1.
Q2.
Q1. See, it will be Q1 only. No, Rashan, it will be Q1. See, reason for being Q1 is that potential is generated by Q1, no? Q2, we are calculating the potential on Q2. So your charge, yes, okay. So your charge will be Q1. So constant is K, charge is Q1. And yes, Kulsum, now in the denominator,
R1.
R12. R12. This will be R12. So this is the potential that we have. Now see, if we write the work done in carrying Q2 from infinity to this point B, Q2 is the charge, VB is what? K Q1 divided by R12. So work done, this whole work done that we are calculating, minus this will be 0. Potential at infinity is always 0. So this will be 0. So work done, this total work done. This is W2. So total work done will be what? W1 plus W2. W1 we had already seen when only Q1 had been brought. Their work done was 0. So total work done will be 0 plus K Q1 Q2 divided by R12. Now this total work done, this gets stored in the form of potential energy. This work done only gets stored in the form of potential energy. So all your potential energy is equal to the work done, that is K Q1 Q2 divided by R. So remember, now this becomes your general formula for 2-point charges. If you have 2-point charges, then K Q1 Q2 divided by R. So if you have charges like Q3 Q4, so it will be K Q3 Q4 divided by R. This is the formula of potential energy, because the whole work done, this gets stored in the form of potential energy. Is it clear to all of you?
Yes, ma'am.
Yes, teacher.
Fatima, Hamza, is this clear now? Just note down. Written, all of you?
Yes, ma'am.
Okay, so this was what? Potential energy between two charges. If the system is if the system consists of two charges, then that was the potential energy that we got, K Q1 Q2 divided by R. Now, if we have n number of point charges, because you can have various number of point charges, you can have 3 charges, you can have 4 charges, you can have infinity. So we should have a general formula that if we have various charges, then how do we calculate? So see, we'll be using the same method only. Graphically only we'll write it. Let's say this is y-axis, this is x-axis, this is the origin. Now I have charge Q1, Q2, Q3, Q4, Q5. At infinity I'm having, it's better to write Qn. That represents n number of interacting charges again. Now I am making up the system, and the work done required to make the system, this only gets stored in the form of potential energy. So I will bring the first charge Q1. Let's say at point A, I have brought this charge Q1. Okay, Hiba, tell me what will be the work done for this? Yes, Hiba. Yes, try, Hiba. We have done this. Just now we have done. If we bring up the first charge, and if there is no other charge to interact with, then the work done becomes what? Hanifa?
I don't know, I'm confused.
See, if you have no other charge present to interact with, and you're bringing the charge, if there is no other charge to interact with, your work done becomes 0. See, that's what we did in the first part. No, when we had done this, what did we do? At infinity, Q1 and Q2 were there. When Q1 had been brought, since there was no other charge already present, so work done in carrying Q1 from 0, from infinity to a point, that becomes 0. So work done in bringing, again we are writing the same case. Q1 has been brought. So work done in bringing Q1, this will be 0. This is what? This is the work done to carry Q1 from infinity to a point. So work done in carrying Q1 from infinity, this will be 0. This is Q1. Now I have brought another charge Q2. Let's say at this point B, I have brought another charge Q2. So this is R1, this is R2, and the separation between Q1 and Q2 is R1. Just wait for 2 minutes. So Q2 now has been brought up. Now see, all of you understand this. Now there are two charges in your system. It means both the charges can exert force on each other. This means now there will be work done. And this is the work done that we have calculated over here. This work done. Charge multiplied by the potential. So what did we get? W2 as KQ1 Q2 by R12. So W2 will be what? W2 will be K Q1 Q2 divided by R12. Now if I bring up Q3 also at say, let's say at C point, I have brought this Q3. Separation of it from the origin is R3. Now Q3 has to interact with what? Q3 has to interact with Q2. Q3 has to interact with Q1. It means how many energies will be there generated now? 1 or 2? See, Q3 is first going to interact with Q1. Then it will interact with Q2. So how many energies will be there?
2.
Two energies will be there, correct. So there will be two energies. So when there were two charges, only single energy was there between both of them. Now there are three charges. This third charge has to interact with the first one and the second one. That makes two energies. We'll see how we'll get two energies. So let's say this separation is R2, 3 between 2 and 3. And the separation between A and C. Let's say this is R1, 3. Separation between 1 and 3 is R1, 3. Now let us calculate the work done. See, W3 will be what? W3 is the work done to carry charge Q3 from infinity to the point. So Q3 is the charge multiplied by the potential. Now, general formula of potential is what? KQ divided by R. We are getting the potential not only because of A this time. Now B is also generating potential on this point C. So first we will have the potential at point A. All of you quickly write me in the chat box. If this is your point C, we are calculating the potential at point C. What will be the value of potential due to Q1? Separation between A and C is R13. Charge is Q1. So what will be the potential? This is the general formula of potential. Quickly, all of you write me in the chat box. Okay, Atif has written. So only Atif knows. It will be KQ1 by R13. Yes. No. Krishna, potential, how will Q3 be there in potential? It's a property of a single charge only, no? KQ by R. You don't have the other charge. So potential at point C due to Q1 will be what? K is the constant, charge is Q1 divided by the separation. Separation is R13 plus. Now the potential will also be generated by Q2 as well. So this will be K Q2 divided by the separation between Q2 and Q3. This is R23. So this is how we write the work done. Now see, you can open the bracket by multiplying it. W3 will be what? K Q1 Q3 divided by R13 plus K Q2 Q3 divided by R23. This is how we'll be writing it for work done. See, it's very easy to write even without doing so much. Let's say there's a fourth charge Q4. See, an easy method how to write all this. Q1 is already there, Q2 is already there, Q3 is already there. Now let's say we have fourth charge Q4. Understand how to write it quickly, because this much time it should not take to you to write all the steps. If you have so many charges, you have to write it very quickly. So how will you do? Remember, the general formula is what? As I've told you, between two charges. It is K Q1 Q2 divided by R. If fourth charge is there, let's take the separation between all the four charges. If Q4 is there, it has to interact with Q1, Q2, Q3. So now the total energy will be, there will be three energies. Q4 will interact with Q1 first, and then Q2, then Q3. Now let's say the separation between Q1, Q4 is R14, Q2, Q4 is R24, Q3, Q4 is R34. See how will we write it. This is the general formula, K Q1 Q2 by R. Firstly, potential on Q4 because of Q1. General formula says K, first charge multiplied by second charge. Q1 multiplied by Q4 divided by the separation. Separation here is R14 plus. Now, if I talk about this charge, Q4, K is the constant will be the same. Take both the product of both the charges, Q2, Q4, divided by the separation. Separation is what? R24. Plus, K will be the constant. Both the product of both the charges, that is Q3, Q4, divided by the separation, R34. So is this clear how to write it? Even if I give you Q5, will you be able to write it now?
Yes, ma'am.
So only, is it clear to Krishna or others also? Akifa, Fatima, Hamza, Hanifa.
Clear now.
Huzaifa, is this clear to you?
Yes, ma'am.
So now this is how you have to write the work done for a single charge. Now we are not calculating work done for a single charge. We are calculating the whole potential energy. It means what is the total work done? Total work done will be, what? W1 plus W2 plus W3 plus W4 and so on till if you have n number of charges, Wn. Now see, how will we write it? All the work done, W1 is what? 0. Q2 is what? W2 was what? We had calculated, if you remember, K Q1 Q2 by R12. This one. W1 is 0. W2 is this. So we'll write it as K Q1 Q2 divided by R12. Plus then W2. W2 is what? K Q2 Q3 divided by R23, and work done, we had calculated it. It is K Q1 and K Q1 Q3 plus K Q1 Q3 divided by R13. So this is what? This is W1. This is W2. This is W3. You just have to write the values. Once you know how to write the value of work done, you just have to put in the values. Up till where? Work done by n number of charges. If you have n number of charges, you can write it in this manner. Just in order to remember it. How are we writing? Constant K is there. Qn minus 1 is there and Qn is there. Means n number of charges are there. Let's say 5 charges are there. So 5 charges is interacting with 4 charges. It means 5 minus 1. So that's why I have taken n minus 1. Divided by the separation between this point, means at n minus 1 point and n point. Just a general way to write it. Basically, we are writing this only, whatever we have studied. We are just writing that only. It's just a method to write. So all this work done, this net work done, this gets stored in the form of potential energy. So the value of potential energy, this will be the same. K Q1 Q2 by R12, then K Q2 Q3 by R23, all the whole values. So you don't need to remember this whole huge formula. What you have to remember? You have to remember, take the charge you are considering. If you are taking Q1, then calculate the interaction possible with Q1. Write it according to the general formula that you have. Take the other charge, calculate the work done on it. Take the other charge, calculate the work done on it. Then ultimately add all the work done, whatever is your answer, that is equal to the potential energy. So just in order to summarize it and write it, you can write it and remember in this manner. K will be there, 1 over 4 pi epsilon naught. Summation I is equal to 1 and J is equal to 1 till N. This will be Qij divided by R1 Rij. This is just a method to write them, and I should not be equal to J. Basically, just to summarize this, mainly you have to remember, you will get it as K Q1 Q2 divided by R. Clear?
Yes, ma'am.
Okay, just noted this. See, note down this question. The first charge that you have is 2 millicoulombs. The other charge that you have is -3 microcoulomb. And the separation between both of these charges is 3 millimeters. So just calculate the first part and send me. Rest of the part I'll do. Potential energy. The general formula of potential energy between 2-point charges is what? K. K is 9 into 10 to the power 9. Q1. First charge Q1, Q2, other charge Q2 divided by R means the separation between both the two charges. So quickly send the answer of the first part, all of you.
Teacher, the first one is 2 millicoulomb, right? Okay.
Yes, it is 2 millicoulombs.
What's the value for K?
Yes, K is 9
What's
into
the-
10 to the power 9. I'll write it. The constant K is 9 into 10 to the power 9. This is that value that you have to use. Akifa, just recheck your answer. See, the mistake that you must be committing is now we are not considering the magnitude. It's not Coulomb's law that we'll write the magnitude of the charges. In Coulomb's law, we used to write the magnitude. No, in case of potential energy, you don't have to take the magnitude. If it is -3, then consider it as -3 only. If both of them are positive, then write it as positive. If you have the negative charge, you can't write negative sign in this. You have to write negative sign if negative sign is given. Yes, Krishna. Correct answer. So try the second part also, Krishna, till the time others are answering. So others also, please respond. This is a very easy question. The formula is also written in front of you. Just make the conversions quickly and submit your answer. Also, Krishna, mention the unit. SI unit you have not mentioned, Krishna. And Atif, there is some error in the power of 10. Just check again. Others also respond. Kulsum, Huzefa, try the question. It's very easy. Q1 you have, Q2 you have, separation you have. Atif, the unit that you are putting, what are you calculating right now? Check the unit. SI unit. Yes, Atif, now it's correct. Kulsum, again, there is some error in the power of 10 only. So just check it once again. Huzefa, Hiba, Hamza and Fatima Munir, you also please answer the direct question. Rishan, your answer is also left.
I have answered.
Ma'am, is there
Yes,
a
yes,
mistake in
Hanifan.
the negative sign or the
No, no.
power is wrong?
Power. Just check your power once again. So Krishna and Atif have given the correct answer. Let's discuss it then. Potential energies general formula is what? Yes, Krishna. Second part answer is also correct. See, potential energies general formula is K, Q1, Q2 divided by R. Now we just have to find out the values of all the terms. Q1 is what? Hanifa, you tell me. What is the first charge?
2 millicoulomb.
So how will you write it in SI unit? Did you convert, Hanifa?
No.
I think that's why your answer was coming incorrect. See, 1 millicoulomb is what? 10 to the power minus 3 coulombs. So this is 2 into 10 to the power minus 3 coulombs. Then Q2. Q2 is what? Minus 3 microcoulomb. So this will be minus 3. 1 microcoulomb is written as 10 to the power minus 6 coulombs. 1 milli is 10 to the power minus 3. 1 micro is 10 to the power minus 6. Separation between them, the separation is 3 millimeters. This is the separation. So 3 millimeters, again, milli is what? 10 to the power minus 3 meters. Now you can see the SI unit. All are in coulomb or meter, which is the SI unit. Now we just have to put in the values. Potential will be what? K is 9 into 10 to the power 9. Q1. Q1 is 2 into 10 to the power minus 3. Q2. Q2 is minus 3 into 10 to the power minus 6. Divided by 3 into 10 to the power minus 3. See, 3 will get cancelled, minus 3 10 to the power minus 3 will get cancelled. 9 multiplied by 2, this is 18, negative sign. And 10 to the power 9 minus 10 to the power 6, this is 10 to the power 3. SI unit will be joules because this is potential energy. So this is the total potential energy. So when we were discussing what was potential energy, what did we decide? That all the system, all the energy to assemble the system, all the work done, that only gets stored in the form of potential energy. It means this potential energy that we are getting, this minus 18 into 10 to the power 3. This potential energy is the potential energy, no, that must have been the work done, which has been now converted and stored in the form of potential energy. It means the second part is asking you what? Second part says work done to make the system. So the work done to make the system is same. This is the work done only gets stored in the form of potential energy. So work done to make the system, remember this is to make the system. This will be minus 18 into 10 to the power 3 joules only. It says whether system is bounded or unbounded. You have to decide. See, if your potential energy, this comes out to be negative, both of these can happen. It can be either positive, it can be either negative. If it is negative, then your system is bounded. Stable, it is in stable equilibrium. If your system is, if your potential energy comes positive, then understand that it is unbounded. So our answer is coming negative. It means our system is bounded. Now it says if it is bounded, what is the work done to break the system? So if minus 18 into 10 to the power 3 joules is required to make the system, to break it, we need the same amount of energy, but just in opposite direction. So work done to make the system. This is just negative of the work done to break the system. So work done to break the system will be what? It will be positive 18 into 10 to the power 3 joules. Easy, clear to all of you?
Yes.
So note down the solution. All those who have not written, then we'll do one more question on this. So this is a square given to you with the side A. Let's name it as A, B, C, D. 4 points on the corners of the square. So Q plus 2Q, this is plus 2Q, minus Q minus 2Q. All these are the charges present. Now, how many energies are possible? First, let us count that. Then we'll write the magnitude or whatever is the formula. Understand this, that see, first there will be energy between plus Q and plus 2Q. So one energy we have. Then energy will be there between 2Q and Q. They will also be exerting energy. Two energies we have. Minus Q and minus 2Q. They will be exerting energies. 3. And minus 2Q will be exerting energy with plus Q. Means 4 energies we have in the system. So do you all agree with this? There are 4 energies.
Can you repeat?
We have to calculate, see, for calculation of potential energy, we have to see how many charges are interacting. So we can see plus Q and plus 2Q are interacting. It means we'll have a potential energy. First potential energy we will have. Then 2Q and minus Q are also interacting. It means they will be having potential energy. Separation is A, charges 2Q, charges minus Q. Then minus 2Q and minus Q are interacting. There will be a third charge, a third energy. Now plus Q and minus 2Q. Both of these are also exerting energies. So there will be 4 energies. So do you all agree with this? That there are 4 energies?
Ma'am, the diagonals also are
Correct.
included.
Diagonals will be included. There will be 6 energies. See, these 4 energies are definitely there. But apart from this, you can see minus 2Q and plus 2Q. Both are also 2 charges which can exert force on each other. It means there will be a 5th energy over here. After this, plus Q and minus 2Q, these are also interacting and they can exert energies. So you have one charge Q, other charge minus Q, you have a certain separation between them. So there will be this six energies. Now see, all the charges are covered. Now there is no possibility of any other energy. We have considered all the interactions of plus Q. Plus Q is interacting with what? 2Q, that gives us the first energy. Q is interacting with minus Q, that gives us the 6th energy. And Q is interacting with minus Q, minus 2Q, that gives us the fourth energy. Similarly, regarding 2Q, we have all these 3 energies. Minus Q, we have these 3 energies. So this is how potential energies are calculated. You have to first see which charge can exert force on each other. Both of them charges can have potential energies. Now we just have to put in the values once we know this. For calculation of total potential energy, Q1 is what? Remember, this was the general formula for 2-point charges. K, Q1, Q2 divided by R. Now see, Q, 2Q, these are the 2 charges. So K is the constant. Q1 is what? The first charge is Q. The second charge is 2Q. Separation between them. Separation between them is small a. This is the potential energy between A point and B point, Q and 2Q. Next we have 2. What will be U2? Potential energy generated by 2. Atif, you tell us.
Minus KQ2Q by A.
Correct. Perfect. See, for the rest, others, listen. K will be there. Charge is 2Q. Other charge is minus Q. So you will have minus Q over here, divided by the separation between 2Q and minus Q. That gives A. Separation is A. Okay, Akifa, you tell us. U3 will be what? Yes, Akifa?
K minus Q minus 2Q by A.
Correct. This will be K. We are just adding what? K multiplied by first charges minus 2Q, other charges minus Q divided by the separation, that is A. So we have U3. Rishan, you tell us what will be U4? The first charges plus Q, other charges minus 2Q. Separation between them is small a. This is the general formula that you have. Yes, Rishan. Rishan, are you able to understand? If you are able to understand, just write yes or no. Then I'll know that you are understanding. Fatima, what will be this U4? Okay, Fatima is having connectivity issues. Hamza?
Ma'am, it will be K plus Q into minus 2Q by A.
Correct. Okay. It will be, you have to add it, K, first charge is Q, other charge is minus 2Q. We are multiplying them divided by the separation A. So these are the four energies. But regarding the diagonal, we don't know the separation between them. But see, this is very easy. AC or this BD, this will be equal to what? I'm writing it separately over here. AC, which is equal to the BD diagonal. This is what? These are the hypotenuse. It means this will be under root A square plus A square. That gives A root 2. If you will see the sides of the square, this is A, this is A. So this will obviously be root 2A. Similarly, this is A, this is A. This will obviously be root 2A. Now, yes, Atif. Your answer is right. This will be the answer. Correct. The total answer Atif has answered. All right, Krishna. What will be U5?
Minus K 2Q by root 2A.
Root 2A. Correct. So if I'm writing positive sign right now. First, it will be K. Charge is 2Q. Other charges minus 2Q. And the separation between these plus 2Q and minus 2Q. This is root 2A. Fine. Huzefa, you tell us the last energy. U6. See, this is U6. Plus Q minus Q. These are the charges. Separation is this. Yes, Huzefa. At least try, Huzefa. First charge is this. Second charge is this. Separation between the charges is root 2A. This is the general formula. K, Q1, Q2 by R. So how will we write it? Huzefa. Okay, Hiba, you tell us. See, Hiba, you have to tell us. Charge is there Q, other charge is minus Q. Separation between them is root 2A. So what will be the potential energy? You write it in this manner, K, Q1, Q2 by R. So just replace Q1 and Q2 with their values and whatever is the separation between them. Yes, Hiba, try.
Ma'am, may I?
Yes, full sum, yes.
KQ minus Q by under root 2A.
Correct. See, this will be what? K, first charge is Q, other charge is minus Q, divided by what? Separation between them is root 2A. Now is it clear to all of you? Huzefa, Hiba? This is how we write it. Now we just have to solve it. So see, instead of writing this, we can do one thing. We can take KQ square by A common. Then it will make our calculation easier. So if I take KQ square by A common, let's see what is left. So from here, only 2 is left. Only 2 is left. From here, I have taken KQ square by A common. So minus 2 is left. From here, Q by A means KQ square by A has been taken common. Minus 2 minus means, minus 2 multiplied by minus means plus 2. Then we have KQ square by A common. We are left with minus 2. KQ square by A has been taken common. This is minus 4 by root 2. And from here we have minus 1 by root 2. So see 2 minus 2, 2 minus 2, this will get cancelled. Minus 4 minus 1 means minus 5. So this is KQ square by A. This is minus 5 by root 2. So if we write it all together, this will be minus 5 KQ square divided by A. All right. So just note down the solution as well. So see, we had seen what? Potential energy between 2-point charges. That came out to be what? K, Q1, Q2 divided by R. Remember all the formula. Potential was what? KQ by R. Electric field was what? KQ square by R. Force was what? KQ square by R square. So potential is KQ1, Q2 divided by R. Now see, we had also seen potential energy if you have n number of charges. Now, if just one special case is left, then your potential energy will come to an end. If you have dipole, then what will be the potential energy? So potential energy of electric dipole. Yes, Rishan, what was meant by dipole? Yes, Rishan. Anyone who remembers what was dipole?
Two dissimilar charges separated by a distance of 2a.
Two charges having the same magnitude but opposite sign, separated by a small distance, that is 2a. So if I have electric field lines, these are electric field, and I place a dipole. Let's say in this is the direction of the dipole. If this is the direction, then definitely this is negative charge, because direction of dipole is from negative to the positive, and this will be positive. So this is a dipole that I have. Now the torque, that is the restoring torque, as we have discussed this previously, that will try to align the dipole with the electric field. If this is the dipole, this is the electric field, it will try to align itself. It can move it in this manner, but it will move in such a manner that the dipole and electric field, both of them, get aligned together. So let's say this angle is theta. If torque is shifting, then it can shift it at angle theta 1, or it can shift it in this manner. This will be theta 2. See, work done is what? Work done if you have variable charge. If you have variable angle, means angular displacement. So work done is F dot dx. Now in case of rotation, because we are rotating the dipole, the rotational analog of force becomes torque, and the rotational analog means displacement in terms of rotation becomes angular displacement. So work done becomes basically torque, whatever is the torque due to external restoring torque, dot theta from theta 1 to theta 2, means from this theta 1 to this theta 2. This is the work done due to the external torque. Now, if you remember, we have done the formula of torque that was related with dipole and electric field. Can anyone tell?
P sin theta.
P sin theta. Torque is P cross E, or torque is, this is PE sin theta. So let me put it over here in the formula of work done. So if I put it in the formula of work done, this becomes integration of PE sin theta d theta from theta 1 to theta 2. Now PE is constant, so PE will come out. Integration of sin theta will be left from theta 1 to theta 2. Now, if you remember, the integral of sin theta, whenever you have integral of sin theta, that gives minus cos theta. So work done will become now what? It will become PE. Instead of sin theta, now we have what? Minus cos theta. Values from theta 1 to theta 2. Now if you put the values of the limits. Means work done will be what? This is minus PE cos upper limit, that is theta 2, minus the lower limit, that is theta 1. This becomes your formula of work done. Work done is what? Minus PE cos theta 2 minus cos theta 1. And this whole work done gets stored in the form of potential energy. So your formula of potential change in potential energy, which is equal to work done, means final potential energy minus initial potential energy. This is minus PE cos theta 2 minus cos theta 1. For example, if your cos theta 1 means your first angle is kept at 90 degrees, it means your dipole is kept at 90 degrees. And now the rotation is beginning, means your theta 1 is 90 degrees. So your potential will be what? Minus PE cos theta. Only theta 2 will be considered. This will be the formula. So you can write it in this manner also. Minus P dot E. PE cos theta dot product. The way we write dot product. One more thing we have done in when we were discussing electric field also. Their energy when we were discussing. You remember this point. Work done by electric field. If the question asks you work done by electric field, then it will be negative of the work done by the external force. Work done will be negative. We have done a question, if you remember, where we had to calculate work done by electric field. So work done by electric field will be negative of the work done by the external force. So if you have the formula as minus PE cos theta, let's discuss this. This is minus PE cos theta. Now you can get a case when this is your electric field, this is your dipole's direction. Means electric field and potential, your not potential, your dipole, both are kept at both are parallel to each other. So your angle will be
0 degrees.
0 degrees. Your angle theta will be 0 degree. So if I put U as minus PE cos 0 degrees, this becomes UE is equal to minus PE. So this means minus PE. Firstly, this is the minimum value. Apart from this, if you have potential energy as negative, then your system is quite stable. If you have potential energy as negative, this shows that this is in stable equilibrium. Because you have a minus sign. Minus sign indicates what? As I've told you, it indicates that the system is bounded. So if the system is bounded, then it means it is in equilibrium. Stable, it is in stable equilibrium. Now, if this is electric field, this is the direction of electric field, dipole is kept anti-parallel now. Means both are facing opposite. Both are opposite to each other. Means your angle is what? 180 degrees. So U will be minus PE cos 180 degree. And 180 degrees minus 1. Cos 180 degrees minus 1. So minus minus this becomes U is equal to plus PE. So this is what? This is the minimum value. Sorry, this is the maximum value possible. This is the maximum value that gives unstable equilibrium. This gives unstable equilibrium. But if I take the case, if the dipole is kept perpendicularly to the electric field, means this is the electric field, this is the dipole that has been kept, means making an angle of 90 degree with the electric field. Then theta is 90 degrees. U is equal to minus PE cos 90, and cos 90 is 0, so you directly get the potential energy as 0. Is this clear to all of you? We are just putting random values. If it is parallel, if it is anti-parallel, if it is perpendicular. You have to remember firstly the formula. Minus PE cos theta 2 minus cos theta 1. If cos theta 1 is not there, means if it is 0 degrees, then only you can consider this that we are writing minus PE cos theta. And if you have minus PE cos theta, you can have such three cases with both of them are parallel, both of them are anti-parallel, both of them are perpendicular. Understood?
Yes, ma'am.
Okay, so just note this as well. And if you're having any doubts, just ask me right now. Just note down this question, and when you have written the question, just text me done. Yes, done.
Done, ma'am.
All right, so we'll discuss this question in the next class. So that will complete your potential portion.